We're up in the mountains, 8 kilometers from the coast. And what's happened here is that the tsunami has created a huge surge which has climbed all the way up the river and then flooded here.
The result is stunning. A new saltwater lake among mountains, miles from the sea.
この裏にね、川があるんですよ。排水堀ってね。それで、通常はね、ほとんど水がないくらいなんですよ。通常は。ところが、津波後ね、1波目は来なかったんだけど、2波目あたりからやっぱり登り始めて、ね、夜のうちに登ってね。そして夜のうちに登ってきてね、知らないてるうちにもうここに水に乗っていたわけです。次の日からね。それからずっと引かないでそのままなってんだね。もう私たちも先代からここに住んでいないともうないの。私だけでも70年なんだけど、こういうこと初めて。70年以上なんだけどね。初めてだね、こういうこと。
The locals here fear the receding waters will expose bodies swept up from the coast. Traveling north, McRae reaches Ofanato. At first, the town seems untouched.
Look over there. Those houses look undamaged. They've got power and everything here. It's just so strange.
Closer to shore, it is a different story.
And as if Ofanato didn't have enough problems, scientists reckon that this whole area, this region, has subsided well over a metre. And in the next couple of days, the region is also expecting the highest tides of the year. The sea is some 500 metres down there, and yet up here we have this. It's a remarkable sight by any standards, a huge tug which has been brought all the way up here by the tsunami. And what's remarkable about it, or what's even more remarkable about it, is that what it says about the size of the tsunami. Because the Japan Meteorological Center have just produced provisional estimates saying that the tsunami that hit this region was about 3.5 metres high. Now we're 7-8 metres above sea level here, and even given the surge, the fact that it could bring that all the way up here does suggest that the tsunami here was a lot higher than 3.5 metres.
Boats, trucks, and cars are dumped on top of buildings, much higher than the recorded height of the wave.
That happens because as the water's pushing through restricted areas like the streets of towns and villages, it's being effectively funneled. And the water's got to go somewhere, and so it goes up as it's squeezed and funneled and pushes material, pushes cars onto roofs, sometimes as high as 50 feet. So in areas, the impact of this will be even greater, particularly where you get narrow streets.
Once the wave starts to pick up part of a town, the warehouses along the dock, the debris and all that, then it becomes more like a glacier. You know, it's a moving wall of debris, and the more mass it has, the more power it has as it comes in. It doesn't really look like water beyond some point. It looks like the entire town is flowing in, and it is. So all the mass of all the buildings, cars, refrigerators, and everything that's in that wall, it's essentially a debris glacier at that point, and it just keeps coming in.
This is Minami Sanriku, a town that has been virtually wiped off the map. 95% of the buildings destroyed. Over 10,000 people, half the population, missing.
This place symbolizes the tragedy more than anywhere. an entire town wiped out by the force of nature.
It's almost difficult to imagine one's thoughts as one sees this coming towards you. And as it hits the coast, it's then picking up all the debris, it's picking up buildings, cars and things, and you then end up with this sort of really quite horrific mass moving through towns, villages, across fields, causing complete destruction.
I mean, it would be bad enough if it was only water, but because it's full of cars and you can't swim against it or flow with it or do anything, you're just like in front of a bulldozer of moving the entire town.
It's funny that when you hear that sound of an ambulance, it kind of actually gives you hope that they might have found somebody alive. Although that must be happening fewer and fewer times between. Anyone who did survive and was trapped would almost certainly have died of hypothermia by now.
At the town of Rikuzen Takata, 25 miles up the coast, rescue workers hunt for survivors and discover the dead.
When they find a body, they put a large stick in the ground with a flag attached to it so that it can be recovered later. It's a fairly gruesome and sad task. In fact, they're not just collecting bodies, they're also collecting personal mementos as well, which they find, like this. I'm afraid what we have here is more bodies waiting to be taken away.
Within days, scientists gather more data from Japan's earthquake and tsunami than from any other disaster in history. Over Tokyo, Professor Roger Billum returns from his aerial survey. The city's vulnerability is clear.
There are 30 million people within about 2 meters of sea level, and a tsunami here, of course, would be absolutely devastating.
Suddenly, there is a problem.
We had a big earthquake just now, so...
Really?
Yeah.
We've just learned from the ground that there was an earthquake that damaged the heliport. They're checking for damage right now. We don't know how big the earthquake was, but it was obviously a very nearby aftershock.
A massive aftershock hits Tokyo, magnitude 6.2. In the week that follows the main quake, there are over 500 aftershocks. This is the actual data from seismometers around Japan. The larger the circle, the bigger the aftershock.
The shaking is now stopped, so I'll just continue landing.
Finally, Billum's helicopter receives the all-clear to land. The helipad is damaged.
I've noticed that the tarmac here, which should be beautifully dark everywhere, in fact stained white in places, and you can see that in fact sand has come out of this crack, and there's another one over there, another one over there. We're very close to the shoreline, and the lurching motion of the ground during the earthquake has caused the subsurface liquefied sands to come belching out on the top.
Here there is evidence of liquefaction, the strange phenomenon filmed earlier.
And over here is an old mud volcano. Old, it's about 3 days old. You can see how the mud came pouring out of the top there. So look, we're 200 miles from the epicenter here, and here's a crack in the heliport landing area. it continues all the way along here. You can actually see down about 3 feet in places. Splits into two here. This goes over here. You can see an offset in the in this trim around the tarmac.
As the Earth's crust shatters during the main quake, new stresses spread along the fault. Relieve the pressure in one place, and it builds up somewhere else, triggering aftershocks.
What you're seeing here is how those aftershocks happened over a period of about a week after the main shock. And that orange region, delineated by those orange dots, essentially